Good evening, everyone. I hope everyone's having a good night. I just wanted to explain the process and how to work number one for the little exam that Tony posted a while back. So the problem was a single pass rolling operation is to be performed on a 1.2-inch thick metal plate that has a K value of 50,000 psi and an N value of zero point 0.2. Rolling process parameters are given below, and you're given all these other parameters that you will need. The question is, well, the questions are to find a minimum final thickness and a max width. So for A, it's pretty easy to do. All you really need is this equation here. Well, one of two equations. And that's the maximum draft, which is equal to the square of the friction coefficient times the roll radius. And you're already given all of this, and you should get a value. What do we have here? It is 0.162 inches. Now, draft is also equal to the initial thickness minus the final thickness. So from this, you already know what the initial thickness is. It's 1.2. So by default, or from using simple math, the final thickness is to be 1.038 inches. Cool, that is part one. Yeah. Nice. So next is the max width. So initially, what I thought was that you could use the volumetric flow rate correlation, and that is simply the initial thickness times the initial width times the initial velocity, or the velocity entering the rollers, and that's all equal to the final of those parameters, TF, WF, and VF. Nice. One last thing I have to assume is this little note here. Assume the width is constant throughout the entire duration of the process. So initial width is equal to final width, and it says right there. So we gotta take that into account. So what you could do in a perfect world is you could try to solve for either one of these two, but since we have the assumption that WO and WF are equal, then you're not really going to go anywhere. It took me about 5 pages to get that through my head. So what do you do? So for starters, you could look at what's available to you in the problem. You have power available, you have the coefficient of friction, you have roll radius, and you have roll speed. Nice. We know two things about power. We know the quantity as well as the equation. So power was equal, and let's get it from here. Where did you go? There you are. So for the power of both of the rollers, let's take that into account. We have 2 pi NFL. Well, Eric, what is N? What is L? Well, N is your rotational speed. Your L is the contact length. Now the contact length, my goodness, a horrible age. The contact length is the length at which it is in contact with the actual rollers. So just picture a little roller right here. The width and the L are what's in contact with the actual roller. And that's really what we're trying to focus here. We have an equation for L, and that is simply R times the change in T all square root. For N, we know what the roll speed is. That's VR equals 20 inches per second. all you really need to do is you simply have to convert the seconds to minutes and the inches into revolutions. Well, this is pretty easy. You just take what you start off, convert that to seconds, 60 seconds over minute. For one revolution is equal to the circumference of the roller, that being 2 pi r, r being 5, and you should get 38.2 revs per minute, or 38.2 RPM. So we know one value of this. We don't know F, but here's where things here's where things come into our favor. We know L. We never saw for L. Silly me. L was to be, I did it before, 0.9 inches. Nice. So you have, you know P, you know N, you know L. We can now solve for F. F, if you were to rearrange everything, would be, let's see here, 9166 pounds, or pound if you want to get really technical. Cool, so we know F. Well, what can we do with F? So for F, we know two things as well, we know two things also, just like power. We know the quantity, and we also know the equation. So F is equal to the average flow stress times the width times L. We can get this, YF, and YF is simply, it's right over here. YF is the strain coefficient times the strain times the, I forgot what that value is, plus 1. This is the true strain. True strain is equal to ln, TO over TF, right? This guy is equal, let's go back here. Where did I put it? Somewhere. 0.145. It is unitless. Cool. So we know K. K was given as 50,000 psi. We know N, which was 0.2. If you were to insert everything, YF will equal, oh my goodness, 28319. Sure, we'll go with it. And I'll just write simply as that. It is 28,319 psi. Nice. So we can now rearrange the equation for F to solve for L. No, W. W is F over average flow stress divided by L. So if you were to insert F, which you know that, you also know L, you know the average flow stress, the width would finally, if you were to calculate everything, 0.359 inches. And that is your answer. So from the other values you're supposed to find, you can easily get that by just looking back at what you just did. You already saw for N, that was 38.2 RPM. You know the contact length, which was 0.9. You know the true stress, 0.145. You know the mean flow stress, which is this abomination. And you know the width, you know the roll force, which is found way back here. Okay, pretty long problem, but I hope this helps. Let me know on GroupMe if you need any other verification, or you just need me to explain something else. I am more than happy to help you guys out. So yeah, happy studying.